Hello everyone, January 6th. Alright, let's do this. Arithmetic slices. Old problem. Given an integer array nums, return the number of all the arithmetic sequences of nums. A sequence is arithmetic if it consists at least 3 elements and if the difference between any two consecutive is the same. Okay. Subsequence, okay. For example, 2, 5, okay. The test cases are generated so that the answer fits in the 32-bit integer. So we want the total number of arithmetic. So just need to figure out how to DP this thing, right? How to DP this thing. So we can say, if I know the total number of arithmetic ending at a certain position, all right, ending at each position. Now we have a new one, so we need to find out what is number of arithmetic ending at that, and then we're basically adding everything together. That will be the answer. So first, second, these are all nothing. So the third one, but how do you determine the third one? You have to go back. So basically the first 3, right, is you just see if it is. Now the fourth value comes in, I can go check its previous, right? I check its previous, and so what do you need to store? I think at each position you need to store not only the count, but with a difference, right? With a difference. So at each position you say, okay, with a difference of 1, what is the result? Of 2, what is the result? So I can see that it can be like a dictionary, right? At each position it can be a dictionary. So at each position, if it is a dictionary, then for each number I go back, right? And when I go back, for each one I check, I know the difference, so I look into its dictionary, see if there's anything, right? If there's anything. You know what? I think it should be the length. We should store the length. Right, so at each position, so it's going to be array of dictionaries. Right, so it's a 2, 4, 6, 8, 10. Okay, so 2 is going to be a dictionary with nothing. It's just empty. We can say 0. 0 is a 1. Right, because the count itself, 0 is a 1. So for 4, yeah, 0 is 1. And look, previously we have a 2. So 2 will be 2. That's it. 6, 0 is 1. And then look before is 2. That will be 3. And look before 4 will be 1. Alright, 4 will be 2. For 8, 0 is 1. 2 will be 4. 4 will be 2. 6 will be 2. Right? 4 will be 2. 6 will be 2. And now for this, 0 will be 1. 2 will be 5. 4 will be 3. 6 will be 2. And 8 will be 2. So on this we have a 3 here, and we have a 4 here, and then we have 5 here, and then we have another one here. But that's not it. Right? We grab this 3, so whenever we have a 5, that's actually quite concerning. Because at this 3, I get it. But this 4, basically we say we have 4 numbers, right? We have 4 numbers with differences 2. And from 4 numbers, you can produce 2 out of it. And in fact, this is 5 numbers. So the difficulty is to count all of them, right? So I need to know which one is the starting point. But the whole point is to avoid a double count. That's it. The whole point is to avoid double counting. So maybe we need to put who is the starting point. The starting point and the count. So you say we store a starting point and a count. So this will be the same starting point. So we come out, right? Basically, we say, okay, this one's starting point is 2, count is 3. Starting point is 2, right? Count is 4. Yeah, this one starting point 2. So we have yet another dictionary. All right, starting point is something, and then we say, what's the count? Oh, not only that, starting point is something, right? The starting point and the difference, right? The difference, starting point, difference, and then count. Like this 3 value. So starting point is 2. Yeah, starting. So it's like 2, 2, right? So starting point 2 with difference is 2. Or the starting point should be, because this is the difference. Okay, this is the difference. So the starting point, maybe it should be the index. Yeah, should be the index. Starting point, okay, so it's 2. Difference is 2. Starting point is 0. Count is 3. Right, so here, 2 again. Starting point is 0. Count is 4. Now we just look. Starting point is 0. Difference is 2. So we have this, we just keep, so this will be 4. Right, and then eventually will be 5. And then this will be starting point is, the difference is 4. Right, so this starting point is 0. Difference is 4. Yeah, this will be 3. So this is what we have at the end. Right? Now this is just by itself. So 5, give me 1, 2, 3, 4, 5. How many basic subarrays of size 3 or more? Right? So we can count. That's basically is 2, 3, 3, 3, 3, 3. So it's be, because count is 1 will be the whole thing. Right? 1, 2, 3, 4. Count is 2 is 1, 2, 3, 4. Count is 3 is 1, 2, 3. So it's be your n, the length minus the size, right? It's always going to be 3. That's what we're starting point. Minus this plus 1. So it'll be this plus, so it'll be 1 plus 2 plus all the way to this, right? So it's going to be n minus 3 plus 1 divided by 2. So it'll be n minus 1 times n minus 2 divided by 2. So if it's 5, that's going to be 4 times 3 divided by 2. That will be 6. 6 plus 1 is 7. Yeah. Okay, we can try this. And to make things easier, no Java. Come on. I'm not gonna do Java on this because it's gonna be. But you know what? Yeah. If we do Java, this is gonna be an array. Actually, it's not gonna be an array. We're not gonna do an array. We're just gonna create a new thing, and the new thing will be for each one as we go through, right? Each previous. Oh, it has to be because they have to go through everything inside. Don't go through everything inside, but so this is gonna be the value. You know what? It may be. It's just a map with key as this, right? So that's fine. And for this, we can just do, because the start is the index. Yeah, you know what? I think Java might work. It might not be too cumbersome. All right, let's Java this thing. All right, so what do we start with? We start with a list. Oh my goodness, a list of what? A list of map. And the map is going to be integer. And we're going to do an int. What do we call this? We call this, we call it DP. I mean, it's not really DP, right? So you can call it DP. And each one, the position, and the integer is going to be the difference. And this int array is going to be the starting position and the count. Starting position and count, right? Array list. Okay, so that's the DP, and we also need this thing. What is this thing? This thing is going to, yeah, it's not going to be like this. This is also going to be a list. Each one is this. Starting with this with a difference, right? Difference, and then this is the length. So we're going to call this, oh, I don't even know what to call this. So DP is the recording. You probably need to, let me do some documentation. DPI is equal to this is the difference. What is this? This is starting point, starting index, and length. Okay. Next, we're gonna call this integrated. Alright. Diff and length. Longest arithmetic subsequence starting at I with diff between adjacent. Okay, so we're gonna call this is going to be a list of Can we initialize? Yes, we can. We shall do that. Int n equal to nums.length. So we're going to say for int I, 0 I smaller than n, I plus plus, dp dot add new hash map, right? That's that. And this is going to be a list of also a map, but this is going to be an integer, so it's slightly less complicated. Integrated equal to new array list. So same thing for int I, 0 I, and I plus plus. Integrated dot add new hash map. But I do believe this one we don't need. This one I don't need. Okay. So we need to handle the first one. Actually, no. We're going to say for int I, 0 I smaller than nums. Dot length. We actually have this. We call that I plus plus, right? So we have the current value, and each time we do dp.add new hash map, right? And then for the new hash map, always put a 0 in there. So we say dp I dp.get I, right? Dot set put 0. Okay. Actually, because I need a starting position, right? I need a starting position, so I need to go through everything. Because I need a starting position and its length. Depending on my starting position, actually I don't know the starting position, so probably shouldn't do that. So we add a new one, and then we need to go, so say for int j, I minus 1, okay, j larger equal to 0, j minus minus, okay, and we need to have a diff, right? We have a diff. So with the diff, we're gonna go into the hash map, right? We're gonna go into the hash map, and if it's not there, we're gonna put a new thing. So I'm gonna say diff is equal to nums I, right, minus nums j. That's the diff between the two values. And then we need to go into that value, right? The diff, we have a diff, so we're going to that value to find with this diff, and what is the starting position? Yeah. What if you have repeats? Yeah, I'm thinking about what if I have repeats. Oh, we're gonna repeat, and they're gonna repeat. Get the then the starting position will be different, right? It will be the same difference, but it will be a different starting index. Huh. A different starting index. So with this difference, right? So with this difference, maybe it should be a new array. Yeah, so I have the difference, right? So for this number and this number, we have a difference. So we go to this number's, this difference, and I need to go through the entire thing, right, to find with this difference. Because with this difference, it might have different starting point. It might start from here, or it might start from there. And it could be different. Yeah, like imagine if I have, you know, this one is 2 as well, right? You have a 2, 2, 6, 8, 10. Then we have 6, 8, 10, but we have 2, 6, 10 and 2, 6, 10. So for 6, difference is 4, but the position, right? The position is different. So the position can be this position or this position, right? There could be 2 different positions, and each position will have a different value. I'm not going through it again. That would be O and tripled. I don't think I need to go O and tripled. I can do another hash map there. You know, there could be another hash map. Yeah. And then we go through this hash map. So what I'm saying is we're gonna do difference and then starting index and then length, which means this is not gonna be this anymore. We're gonna call it a map of integer and integer. Okay, how about integrated? Integrated means integrated I is starting from this with this, starting from this with this difference, right? With this difference. But there could be multiple. This is actually getting more and more complicated. Because you can have duplicates. Again, right, we start from 2, right, where the difference is 4. Like if I have 2, 6, yeah, exactly. Hold on. I need to kind of just show myself. We can do 2, 6, 6, 8, 10, right? We can also do 2, 2, 6, 8, 10. I believe these two shall be the same. Like a 3? Oh, I have 2, 6, 8, 2, 6, 8. Right, and then 2, 6, 10, and 6, 8 would be 4. Which means starting from 2, difference is 4. I have. So you have difference, and you have the position. You know what? I need to reconsider this whole thing. Yeah, I'll do this one more time. So, like in this, right? 2, 6, 6, 8, 10. Because at the end, what I want is ending at this position. What's the total number, right? That's what I want. Okay, so ending at here, what's the total number? Which means, so ending at this, ending at this, ending at this, the total number, ending at this, what's the total number? So at each position, ending at this position, I need to know what's the total number ending at, that's the DP idea, total number of arithmetic subsequence of any length, but ending at, has to be ending at this position. So we're ending at here with difference is 0 is 1. Ending at this one with difference 0 is 1. Okay, with difference is 4 is 2. Ending at this with difference is 0 is 2. Right, with difference is 4 is 1. Right, ending at a certain position. The total length. Ending at this, right? Ending at this with difference 0 is 1, with difference 2 with difference 2 the length. How do you count this? Yes, exactly. How do you count this? How do you count this 68? And this. Ending at something. Or should we say length is... What should we record? Ending at a position. Okay. We say the total number of subsequence. So the next one I check is the difference. So we're looking into this one. We check, okay, the difference is this. The ending at this. We have how many, right? How many? Or the length. We check the length. Again, we say difference is 0, length is 1, count as 1. Length is 1, count as 1. Length is 2, count as 2. Count as 1. Like over 1, length is 2. The same thing. Length is 1, count as... Hold on, I'm just one more time. Okay, ending at this, difference is 0. Length is 1, count as 1. Difference is 0. Length 1, count as 1. Hold on, let me split them out. 6, 6, 8, 10. Okay. Length is 1, count as 1. Difference is 4. Okay. So when difference is 4, I look into this. This doesn't exist. Right? Or you can say, yeah, it doesn't exist. Then length is, difference is 4. length is 2, count is 1. We have one subsequence with length 2. So this is the same. So this one, length is 0. Okay. So count, not length is 0, difference is 0. Okay. Well, look forward. Difference is 0. So this is difference is 0. We have length is 1. We have one length. We have one of them with the length count as 1. So here, difference is 0. Yeah, I guess you don't need to do this. So we just say like, if it doesn't exist, difference is 0. You have a length is 2, count as 1, right? Length is 2, count as 1. So this difference is 4. You have a length 2, count as 1. Now you go to 8. Okay. 2. So difference is 2. It doesn't exist. Length 2, count as 1. Boom, difference is 2. Length doesn't exist, so length is 2. So the count you need to up, so count is 2. Go here, difference is 6. Length 2, count as 1. Now you go to 10. Difference is 2. Okay? Difference is 2, it exists. So length 2 has 2, which means length 3, count is 3. No, count is 2. Length 3, count is 2. Yeah, this is like 6, 8, 10, 6, 8, 10. Okay, that's done. So now this difference is 4. We have previously length 2, count as 1, so it'll be length 3, count as 1. Go here, 4. Length 2, count as 1, so length 3 will add a count, so that will be 2. So this answer is 4. This might work. So the first level is the difference. Okay, for each difference, we say the length. What is the length? How many different subsequences with this length? And then it will be a new length. You want to try this idea? So, what will be different? Let's just delete everything. So I say, because I have to go through everything, so it's going to be a list, right, of map, integer, map, integer, and integer. Call it dp. Okay. And then first one is empty. So we just do dp.add new hash map. That's the first one. Actually, no. We can just say for I plus plus. Okay. So we put it here. Okay, every time we add a new one, and then we go for the previous int j large, no, j equals I minus 1, j larger equal to 0, j minus minus. Okay, so first let's get a diff is nums, that's called di nums j, no, I minus num j. Okay, so that's the difference. So we check, right? We check, which is say if dp dot get j dot contains key, the difference. Okay, then we do something. Otherwise, if it does not contain the key of this difference, that means we need to create a new one for myself, right? I'm gonna create a new one for myself because that's a new key for this. Then we shall say, okay, we shall say dp dot get I dot put if absent, so will be the difference and new hash map, right? Put if absent, and then what we're gonna do is dp dot get I dot get the difference, right? dp dot get I dot get this difference, get I dot get difference, and then dot put so what's the key is the length, right? Because this doesn't exist, because the di doesn't exist for the j, right? This di doesn't exist in this j, which means j will be the starting position for the, so the length will be 2 and the value shall be dp dot get I dot get di dot get or default 2 0, default should be 0 and plus 1. That is what we're gonna put it, right? So the length is 2, right? The length is 2, but if previous I have length 2, then we just add a more count. This is the count. All right, hold on, I'm gonna do a, so dpi shall equal to diff, and each diff is length and frequency of the count of arithmetic subsequence of such length. So that's that. Now here, if it contains this difference, okay, if it contains this difference, then we're gonna go inside dp.getj, right? dp.getj is going to be this dp.getj, so this is dp.getj .get di. So what's this? This is going to be a hash map with the key being the length, right? Key being the length. The value is going to be the count. So we're going to go through all this length. Okay, we're going to go through all this length. Right, so what we need dot key set values. We need key set. Okay, so key set. So I say for int L of this key set, right? For this key set, dp.get I you know what? I think this line shouldn't be here. I think this line should be here. Right, like no matter what, we get the difference, we should put a new hash map. Put if absent. So we get a new hash map. So dp.get I will have a hash map, right? So if it doesn't have, then I get I dot get so this is the first level hash map, right? And then this is a hash map. Put if absent. So we put the di in, right? And now we get a hash map. Now we get di.put. This is correct. This is gonna be .get this, okay? .get di, right? .get di. That'll be the hash map, and then with the previous length. So we shall .put, okay? The previous length plus 1. Right? And this is gonna be dp.get I .get di .get or default L plus 1. Do we have at this point with this difference the same length, right? If we have, then we get our default. This default should be 0. Don't have, and plus. So whatever previous we have now should be dp.get j.get di.get this L. Makes sense, right? dp.get I, so we put that in, and dp.get j, if it contains di, then we go into this di, we go into the length. For all the length, now I'm going to add to it, so the length will be plus 1. Therefore, it's, therefore we have this plus 1. Right, when I put plus 1, we're going to get a new length, not new length, new number of counts of this. So we go to my I, go to my di, right, and then we say get our default. L plus 1 is the new key, right, the new key. And if it doesn't exist, we do 0. If it exists, we get however many we have for that. And then we need to plus whatever the count of the previous JDI has, right? So we do that. And we do, this is if it's not. So the previous doesn't have, so we do plus 1. Yeah, because this is the first one, right? This is the first one, and this is so input 2. Basically, previous L you can consider as 1, but I do this check. So go all the way back. So okay, now I want to make this look a little bit nicer. Okay, so let's make this a little bit nicer. So we shall say a map of integer and integer. We're gonna call it len count equal dp.get I.get di. Okay, so with that, this is fine. So okay, so len count I count, IC, okay? And then we say map integer, JC, dp.get j dot get di. Okay. So now this is going to be dot get di. What if it doesn't contain di? Okay, so we'll do it here. Right? Because this is contained, so I can do the JC. And for every dp dot get I dot get di, okay. Well, change this. I'm gonna IC. Next, come IC. Next, IC. Next, IC. All right. And of course, this will go in here. This one is gonna be JC. Okay. So if this contains, I go JC. Otherwise, it's gonna be IC, right? IC put 2. IC get defaults 2, right? And then we'll plus 1. That is correct. Or IC dot put the this is JC, right? JC dot key sets. JC dot key set. We get a key L and L plus 1 because we'll extend it by 1. And there'll be IC dot get default L plus 1 and then JC dot get L. So okay. Once we're done, what are we gonna return? So once we're done, we go through every single thing, and we go to the last one. So we go in the last one, and we will have the count, right? The count. So now we can say int res is equal to 0, and I'm gonna go through the last one. No, that's not right. That's all we do is say ending at a certain position, how many, right? Ending at a certain position, how many? And oh yeah, if it's ending at a certain position, then we should just add it throughout, right? We shall just add it throughout. So what I'm saying is we do this earlier, okay? Why always add another one? I don't know. So we get the rest. So each position, right? For each dp da. So once we're done, we go through this and just count how many we have, because these are all ending at this position, which means we should do one more for int length again of dp dot get I, right? dp dot get I dot key set. If L is larger or equal to 3, then res or plus equal to dp dot get I. No, the first level. Ugh. The first level is difference. Oh my god. Oh my god, the first level is difference. First level is difference. And then we get a new one with a count. shouldn't we just do it here, right? Right, we record. Because if you have, that means previously must be at least 2, right? So now you plus 1 will become 3. So that we shall get is the total count, right? That's the total count. The previous count will increase, yeah, and then you have previous, 2, you have 3. So this is it. This is the one, right? No, but this says with difference and this count. Yeah, no, because you go through everything, you might. Ugh. I think rest plus equal to jc dot get L. This L, right? So you don't do it here. D3J. Yeah, this results just add this. Because this is when the previous must be 2, at least 2, right? So you add current, so that become a valid arithmetic subsequence. And then how much more, it's the jc dot get L. So you get this amount. And then if you repeat, you get it again. You repeat it, get it again, doesn't matter. So at the end, once we're done with all that, we simply say return the rest. All right, it's very, very important. We are going to test on all of them. So 22K.
Oh.
So these are 2 simple cases. Let's make sure these 2 are correct, which they are. Then we are going to, we can just copy and paste these things. These 4 cases. This is a very interesting case because I never tested on this. And that is, and these are all not correct. All right, output is 4. That is bonkers. Okay, so let's go back to the drawing board and analyze this 2. Let's get a new one. 2, 4, 6, 8, 10. Okay. 2 is empty. 2 is nothing. Okay. So now 4. I say the difference is 2. Okay. And does this contain 2? No, it does not. So I'll put difference is 2, length is 2, will have 1 count. Right? Done. Now this 6. Go here, difference is 2. It does contain, okay? Then we go to its key set. So key set 2, which is length is 2, which means length is 3, will get 1, because that's 1, right? Length 3, have 1 count. That's it for this one. Difference is 2, length 3, get 1 count. And then we go here, difference is 4, length is 2, gets 1 count. So in this case, I have count as 1, right? This is 1, ending at 6, we have 1. Now ending at 8. Difference is 2. Difference is 2. This, I think I know. So this will be count as 4, right? Count as 4 with 1 count. Now that when you have count as 4, you need to add, because that's 4, and also ending at this if I have 4, that's going to be 4 minus 3 plus 1. Minus 3 plus 4 minus 2. There's 2, because I can do all 4 or the 3. So that is where we losing. So this is +1, right? But this length is 4, we have 1 count. Okay, and then length is 4, we have 1 count. 10, 2. So this shall be plus, this is the length minus 2, so plus 2. And this is 2, we have 5 with 1 count, right? 5 with 1 count. Now I have 4. 4, we have 3 with 1 count, right? And then we have 6, doesn't have, 8 doesn't have, right? Oh, it actually does have 6 as well, but we don't have to count. So 5 minus 2, we have plus 3. This will have plus 1. So 1, 2, 3, 4, 5, 6, 7. Which means here we shall do this minus 2. Right? So we say, for example, if the length of the sequence ending, right, ending at, that is not correct. This is the count. Oh, this is not right. This is the count. It should be the count times your length plus 1 minus 2, which means this is 1 minus 1. Right? Yeah, so yeah, this one requires explanation. So jc.getL is the count of subsequences of length L, right? Ending at nums j. Okay. Now, this means we have just added jc.getL, number of subsequences of length L plus 1, ending at nums I, right? Now, for each such subsequences, for each of these subsequences, their length must be larger or equal to 3, and they can produce L plus 1 minus 2 equals L minus 1, number of arithmetic subsequence. So with that, I waited. Still not enough waiting time, huh? Ugh. Damn it. 7. What happened with all 7? Okay, I can just produce a simpler 7, 7, 7, 7. How about 4 7s? That should be the simplest. Let's see if it's correct. Oh, 4 of them is correct. 5 of them is wrong. All right. Okay, let's do this. 7, right? So 1, 1, 2, 3, 4, 5. Okay, so this one should be 2. Length is 2 is 1. Oh, 0. My bad. 0 length of 2 is 1, right? So this is 0. Length is 3 is 1. This is 0. Length is 4 is. But length. Hold on. The length of 2 is 1. And length 0. Length is 2 is 1. Length is 4 is 1. 3 is 1. And 2 is 1. So 3 is 1. And length 2 is 1. And this is 0, 5, 4, 3, 2. And that's it. Okay, so here, that's plus 1. This is plus 1 plus 2. This is plus 1, plus 2, plus 3. So 1, 2, 4, 5. Wait, hold a second. This is not right. This is 1, right? So here we have 1 is 4. So this can produce 1 and 2. And this can produce 1. Right, so that's 3. So I have 4. 2, 3, 4, 5. And for this, I have this is 5. So we can produce 1. Ending at this 1. I say 1, 2, 3. Ending at this. Right? 4, 5. Ending at this. 7. 7 so I don't have 11. Wait, what? I don't even understand. Wait. What the hell? Okay, that's 1. And then we say ending at this. Okay, well, ending at this, how many? Right, so I check this, and its difference is 0. So we check difference is 0. For this, we can have 3 was 1. Or 2. Yeah, we have 3. Ending at this 3 was 1. Ending at this 2. Oh, that's not right. That's not right. Because ending at here. Basically, we're asking ending at this, right, where the difference is 0, where the length is 3. Okay, we have 1. But length was 2. Shall be 2, right? This one shall be 2. So first of all, I don't understand why this will give me 17. Okay, that's definitely not right. But let's just not get worked up on this. Let me just recalculate this, right? The length 3 is 1, but length is 2. Why is this 1? Because I come here and ignore. You have ignored that this one with length 0 has a count of 1. Right? This is what you ignore. Length 0 count as 1. So when you come here, length is 0. I have a count 1, and then go here, so length count 1 and 2. So this count 1 is 1, and then we go here, right? So this is 0. So count is 2, so it becomes 3. Count is 2 becomes 1. Count 2. So this counter 2 is actually have 2. And everyone should have a count 1 is 1, right? So count 4 is 1, right? And then count 3 is 2. Count 2 is 1. Count 1 is 1. Go here. Count 3 shall be 3. And here, count 2 shall be 2. Count 2 shall be 2. Shall be 3. And I go here. Count 5 is 1. So this is plus. That's not right, right? So it'll be plus. This is plus 2. This will be plus 3. Because I have 3 of these. And here, count 5 is 1. No problem. Count 4 will be 3. Count 2. Yeah, count 3 will be 3. And count 2 will be 2. That will be 1. Count 1 will be 1, right? And then we go here. So count 4. It should become 4. Right? Count 3 become 5. Count 2 become 2. Count 3 become 6. Count 2 become 3. Count 2 become 4. So it'll be 6. So this is minus 2, right? So it'll be plus 3 plus 4 times 2 and plus 6. This is 17. Which is ridiculous. The answer should be 16. And I'm supposed to add them all together. So it's like plus 1. This is plus 5. 1 plus 5 is 6. 23. Yeah, there's definitely some overlap. Some shady stuff that I didn't... No, I think it's in this way. Count 5, you just count 1. Right? So what if we recompute this? This is plus 1. Ending at this length 3. Ending at this length 4 is plus 1. Ending at this length 3 is plus 3. Okay? Ending at this is plus 1. Plus ending at this is length 4. We have 4. length 3, we have 6. 1, 2, 5, 6. 16. Okay? 16. So we'll do some modification on this one. So we shall add this and always add length is 1. Count is 1. Length 0. Length is 1. Count is 1. How do I do this? dp dot get I dot put always put 0 new hash map, right? And dp dot get I dot get uh, 0 dot put, right? Length difference is 0, length is 1, count is 1. Okay, we're gonna call this initialization. Then as we go through the whole thing, okay, we get a difference, we get the previous, and then we say I see, yeah, it's fine. So it's this, and we'll put this, and then we'll do this, and then the difference, right? Yeah, if the difference is in there, if the difference is not in there, we'll get the length will be 2, right? Length is 2, and if it's in there, the difference is in there, then we go through the difference. JC is that with the difference, and then we go through each one of them, and then that's going to be plus 1. Don't get our default, the previous one plus this, and then rest shall plus equal to just this thing. Let me think. Yeah. What should I plus or equal to? Each time I add it, right? Each time I add it. The original, and each time I add to put into this new thing. Because when I start to get I don't have anything when I start, right? I get a new thing and I don't have anything. And then each time I get, so shouldn't I just plus equal to JC dot get? I just get that, right? Let's see, is this one right? What the hell? $26. Well, we have to say if L plus 1 larger equal to 3, I got 16, 4, 3. Now the problem is with the first one. Let's try it again. 2, 4, 6, 8, 10. So each one we have 0, count 1, 1. 4 is like 0, count 1, 1. And then 2, count 2, 1. Right. And here we have 0, count 1, 1. And then 2, difference is 2, and I will count difference is 2, we have length 2, so it will be length 3, right, count will be 1, this difference is 4, right, length is 2, count is 1, so this is plus 1, because I have 1, and for here, again, difference is 0, we count 1, 1, difference 2, we have difference 2. Oh, each difference you need to have a 1. Each difference you need to have a 1. Holy crap. Not each difference. Yes, each difference. If you get a new difference, you need to put a 1. Length 1 should be 1. So what you're saying is here, that get I put if absent, right? And we should say IC dot put if absent 1, 1. Right? This is length 1, we should have 1. And in here, length 1 should have 1. Unless it's already there. It's always going to be 1. So I just put. I don't even need to check if absent. I think it's always going to be this. There we go. There we go. What the hell? Oh, overflow? It's okay. What I need is this shall be a long. Hold on. Let me move back here. So this is fine, but this shall be a long just in case. Okay. So the difference. So this should be a long. Okay, good. Yeah, I think it's good. Okay, let's see. We do a long. Does this one work? Still doesn't work. Output still 1. How? Yo, stupid. DI is a long. Oh, I think this. I have to coerce it into a long. There we go. Coerce into a long. Oh, 1 hour 22 minutes. Not my proudest, but hey, it's we got it done. We did it last time too, but I wonder what type of method I used last time. This is quite, I mean, it's not really that hard, but the doing in Java is definitely not the right choice. All right, that will be it. I will